This presentation will explain how to calculate the sling stress acting on a load. The most important concept to know about sling stress is that as the sling angle decreases, the sling stress will increase. In the example shown, the sling angle decreased from 90 degrees to 60 degrees, but the sling stress increased from 1,000 pounds to 1,155 pounds. Let's take a closer look at how we can calculate the sling stress. To calculate sling stress, we will use the following equation. Sling stress is equal to the load weight in pounds times the load angle factor divided by the number of legs. In this example, we are lifting a 2,000 pound load using 2 vertical wire ropes at a 90-degree angle. The load is 2,000 pounds. The load angle factor is found using this table. And the number of legs is the number of wire ropes used to lift the load. Since the angle of the sling in this example is at 90 degrees, we will use a load angle factor of 1.000. Now we can substitute the values into the equation. 2,000 pounds times the load angle factor of 1.000 divided by the number of legs, which are 2, will equal to a 1,000 pound sling stress in one of the wire ropes. Therefore, our total sling stress is 2,000 pounds. Let's look at another example. In this example, we are still lifting a 2,000 pound load, but now the sling angle has decreased to 30 degrees. Therefore, the new load angle factor is 2.000. The load is still 2,000 pounds times the new load angle factor of 2.000 and divided by the number of legs, which are 2. The sling stress in one of the wire rope slings is now 2,000 pounds. The total sling stress is now 4,000 pounds. We can see that as the sling angle decreased down to 30 degrees, our sling stress doubled. A rigger must understand the specific type and amount of stress placed on rigging components. If calculations are not made accurately, the rigging could fail and damage the load or cause injury or death in workers.